Hey guys, all right, here we go with day 7 AMI question. So, go up here. All right, so it says a taxi driver records the time required to complete various trips and the distance for each trip. The best fit line is given by this equation, okay? And so we remember anytime they give us an equation, it's important. Okay, so I'm just going to come over here and write that again. All right, and this is the best fit line, or the line of best fit. Okay, it's describing this line that is going through the data. That's the line that makes it possible for us that if this line were to continue, we could make predictions or estimates about what we think that data is going to do as that line continues. Okay, so we know it's not completely 100% accurate, but it's the closest thing we can do to make predictions or estimates so that we can get pretty close to the actual value. Okay, change colors. Okay, so it says or y represents the distance in miles, which we can see is labeled in our y-axis, and then x represents the time. Okay, so let me just go ahead and label those things on my graph. Okay, now it says use the best fit line. Okay, so again, we use this equation to estimate the distance for a trip that takes 20 minutes. Okay, so it wants us to use that equation to estimate the distance, and it tells us that the trip takes 20 minutes. So if they told us what it was in minutes, then they're giving us the x value. Okay, so for part A, we're just going to rewrite that equation for the line of best fit. All right, and then it told us that it was going to take 20 minutes. So it wants us to solve for the y value, which is the distance. Okay, so I have an equation, I have a variable. What do? I know that I am supposed to plug it in. Okay, so I'm just going to say y equals, there's an x, I know that x equals 20. I'm just going to plug that in or substitute it. We talked about in day 5. Okay, so I'm just going to simplify that. So I have 0.467 times 20 plus 417. Okay, and so if you were to type that into your calculator or just whatever you have at home, 9.757. We're talking about distance, so it's in miles. Okay, so there is your answer for part A. All right, now let's look at B. It says, again, use that best fit line to estimate the time for a trip that is 6 miles long. Okay, so this time they told us it was 6 miles. So if we're talking about miles, we're talking about the distance or the y value. Okay, so this one's going to be a little bit different, but ultimately the same. So we're going to use that same equation that we used in part A. And we know that our y value equals 6. And this time we are solving for our x value. Okay, so I'm just going to substitute that 6 in. So now that 6 is going to be where my y is. All right, so now I'm going to solve this equation for y, or for x, I'm sorry. Okay, so I have to get rid of the terms that are with it. So I always start with the term that is farthest away from my variable. So I have a positive 0.417, so I'm going to subtract. I'm going to do it to both sides. That's going to cancel out over here. And on the other side, I'm going to get 5.583. And that equals 0.467x. All right, so that's saying 0.467 times x. So in order to get that x by itself, I need to divide it. I'm going to do it to both sides. Okay, so I'm just going to take my calculator. I'm going to then divide it. And my x equals 11.95. Well, the other 5 would run that to 6 minutes. And there you go. That's how much time it would take. And that's it for day 7. And if you have any more questions, please send me a picture in an email letting me know what you need help with. I really hope these videos are helpful. I know they're probably not the best quality for some reason when it converts on YouTube. It kind of makes it sort of fuzzy. So if I can find a way that makes it not do that, I will do my best. But until now, this is the best option. So again, just send me any text if something's hard to read or whatever you need to do. All right, see you guys.